think that puts us live here shortly, so let us go to music. Is it already broken? There we go. Okay, and we are now on YouTube. Mr. Wiggly. We are now on YouTube. Where are we at? Oh, look at that. I'm on my own front page. Bum, bum, bum. Whoops, I said okay. No, it's not okay. Run away. Okay, so here's what we're hoping to work on. Actually, we do need a texture. All right. Fine, bring textures into this. Why not? So basically everything I've been doing with the procedural asteroids, I'm going to take, because, well, of course we want this to be as optimized as possible, so we're going to put the transforms into the vertex shader. So basically for that we need the grid XY, we need the scale, so the quads will be scaled. We need the rotation, and then the center point. And then we're going to translate this, we're going to also pass this through to the geometry shader and see what we can do. We're going to just see what we can do. So I think the first thing would be textures, although I just now thought of that. So I was trying to plan it all off stream and then just be like, okay. But no, that didn't work out. Doesn't work out. All right. So what is this one here? Main updated geom. Okay, so to get textures, yeah, we need a few things here, Jeff. Actually, we can include that class. We're going to pull it, wait, asteroids. Oh yeah, we should. Well, we'll probably look at that. Okay, all right. Yeah, okay. That's what I meant to say. We'll probably look at that class. That's probably exactly what we're gonna do. So main updated, and let's put these in here. So we're actually including STB. Okay, so we define STB image implementation, and then STB image, our little friend here. Okay. This is very exciting. Let's just, because this works, version 2, I modified the geometry shader. I modified a lot. Let's go with that. Okay, so let's save this now as version 2. Bada boom, bada bing. Okay. Excellent. Remove. Source files. Add. Existing. There's the newest one. Okay. Then let's up the geometry class, updated geometry random. Let's go with geometry asteroid one, basically. Yeah, okay, cool. And then we're going to change the geometry shaders as well. So let's go into here, file, save as. This is not a very big class. Yeah, we're using it for the asteroid. So let's call it something. I don't really care, actually. I really don't. I don't care. I'm going to leave it. Fine. Fine. All right. Feeling cheeky this morning, Jeff. No, I just haven't had my orange juice. And really, there's nothing really going to change that much. This will change a little bit. And then we'll have time var. I don't think we're going to use time. So in this next one we can get rid of that, but okay. Because we're putting in the textures, we're going to have to initialize the texture, and then, yeah, that's fine. This is a really good refresher for me for all the basic stuff, so. Okay, so down here, oh yeah. Okay, so let's get rid of the BK parts for now. 1 and 1, okay. So we have the vertex shader. Okay, that'll change. Fragment shader, okay, and the geometry shader, okay. We can actually include a texture and then still keep this stuff, really. These can be the center points. But no, I don't want to hard code my stuff, so we're going to change this all up. We're going to upgrade it all. So here, let's go like this. This is now 2, okay. This is going to be 2. Okay, that'll probably change. This will change a lot. Everything's going to change a lot. But there we go. Okay, so random. And I know we're still calling it random. We are. Alright, there. Okay, so we have everything changed over to the new version. We can do whatever we want. Excuse me. Let's run it and see if we broke anything. Computer. Nope, didn't break anything. Okay. Beneath the ice. That's cool. Isn't that cool? Starts out cool. Alright. Let's see. So what do we need? Actually, can we load this up real quick? Computer, will you be kind enough? Thank you. And this, we have this. Okay, so in this BK Asteroids one, here, vertices. Oh, see, this is what we want. We want the quad and the indices. We're going to draw with elements instanced. And then, oh, we're going to use these? Oh, yeah, that's right. These are the groups. Right. I forgot about the group thing. Hello, groups. Although for the purposes of this, I don't care too much about that, but we could maybe use some of these guys. That would be cute and funny. Okay. Okay, we could go with the groups. We could just use random as well, just for whatever I'm doing. So, all right. Nice to know we have the groups there. So let's take this. We're stealing this. Copying, Jeff. Copying. Imitation's the highest form of flattery. Oh. Okay, vertices, indices. Okay, VAO. Now we're going to need a VBO because we're going to send data to the GPU. Atma is now playing Final Fantasy XIV. Oh. Just in case he wants to tune in, I'll send him a link. We'll see what he says. You're funny, Jeff. Okay. Wait a minute, just in case. Just in case what he says, we'll move over here. We'll move that over there because I really just want to see chat. And we're good. Okay. Blah, 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 blah. Okay, so we have the vertices, we have the indices. In order to get the texture in here, we're going to have to steal further. Right, we need an unsigned integer for the texture. So let's just call it atex, I guess. That's fine. Then we come down here. Okay, so we need a function, and let's just steal it. Right here. And that's the texture that we want to use. It's already in there, so. Okay, great. This is great. This is going great. I haven't done anything yet. Don't ask me where I got this class name. We can call it D&D init text. That's fine, actually. Okay. So then we're going to load it. This has got to be atex now. This has got to be atex. Okay, so that'll load the texture. Let's call that from the main function. So load shaders. Okay, so init text is usually data gtr1 dot init text. Computer, not helpful. You're supposed to read my mind here. There we go. Okay, so that loads the texture. Okay. All right. Okay, so if the first thing we want to do, we could just jump right to the geometry shader. But what I want to do this really, really step by step and just kind of see what happens when we first do this, then do that. So we're going to go with the vertex shader first. We're going to do a transform in the vertex shader. Okay. So let's look at that. How would that? What do I need to do to make that happen here? So, okay, we don't receive any data. That's not good. We just have these points right here. Okay, so, all right. So is it in the space arena? Yeah, it's actually, it's in here again, so. Init VABAO. There we go. So, yeah, we should probably think about the data we're going to send in, too. Well, for now, we're going to draw the 10 by 10 grid. We're going to draw the whole thing. We're not going to worry about on or off yet, although that is in the plan. See, on or off bit. So we're working on textures, and then local transform with scale and grid, and then on or off. I think the on or off is going to wait until later, but we're definitely going to get the rotation and the world transform. So we're going to get everything else. So let's move, I know I'm being weird, but let's move on or off down here. We'll make it an add-on for later. Okay, so textures, laugh out loud, what? Shoot, I've got notifications on. I'm actually at work, so I took a few minutes to do a quick quest in FFXIV and make sure my account was active. Ah. Well, I'm at work too. Right now. All right, here we go. Let's see. Yes, it is funny, dude. It is funny. I'm telling my friend I just applied for Subway, and if I don't hear from them by Monday, I'm going to apply for McDonald's, and I'll be flipping burgers and making video games. So, okay, let's get back to this. Seriously, though. Okay, so init texture, there's your vertices with your texture coordinates. I know my brain is waking up. I might need orange juice to make more of this happen, but oh yeah, so in order to send in data, we might need this too. I think we'll need this, so let's just copy this, and then we'll see what we need. Wait, we already have the this, but that is not good enough. So we'll just boop, overwrite that. Okay, so this is the wait, what's it called? Eventually I'm going to want to use this in the program itself. So let's go with, oh, let me just acknowledge that. There we go. Let's just leave it all the same. Okay, VAO, VBO. EBO. Right. How could I forget that? EBO. There we go. Element buffer. So we need a buffer for storing the elements, which is the indices into the vertex array. So vertex array object, vertex buffer object, and the EBO. Okay. Element buffer object. I know what I'm doing. Size of, okay, so we're just, so what are we sending in here? Oh yes, and also size of indices. Isn't that right? Pretty sure. I'm pretty sure. Oh yeah, we don't want this. And bum 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 bum. Make it look pretty there. There we go. Okay. Oh, excuse me. Okay, vertices, offset size of vertices. Okay, this is now indices. Indices there. Copy data. Okay. EBO. Toot, 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 toot. Oh, there we go. Okay. Yeah, we're going to need another thing here. Oh, wait a minute. We don't actually put the indices in here. But we will be using more data. We'll be... Yeah, I should put this together better. So what are we going to send in, actually? Well, right off the bat, we're going to assume it's a 10 by 10 grid. And the quad scale, let's assume we know the scale. So we just need a rotation. Jeff, that's easy. That's a float. What the hell? That can be a uniform. All right. Calm down. Calm down. A uniform. That's a good idea. Hadn't thought of that. Okay, we're not going to use the time in this one. Take out the time. Start to get serious here. I don't know what you're doing. Okay, size of indices. So actually, we're not going to use that in there. So we're just sending in the vertices. I will wait to explain more on that later, I guess, because the indices go in the element buffer object. I forgot about that until I saw this code, and then there we go. So really, the vertices are here, and the texture coordinates are there. Okay. And then we don't need this stuff. This was extra stuff. Okay, 2, 3, 4, 5. That's your, yeah, we will put that in eventually. We'll have to come back and get that. Unbind, bind, okay, whatever. We don't care about unbinding too much. Okay, 0 and 1, size of float, size 5. Okay, so that works. Right there. Okay, I'm sure I'm missing stuff, but stay tuned because we're going to put it all in here. We're going to put it all in. So this is where I get the 3 from for the position and then the texture. And then let's... right. And then for the vertex, actually let me just open another one here. Let's just look at the this one. I know I closed it earlier, but do you trust the author? Yes. Remember my decision for all workspaces? Yes. Here it is. Okay. So there's your version and then the position and yeah, whatever. We just need that and that. Okay. Foop. So we're going to get in a vector 3, that will be the position, and then we'll get in a vector 2, A-tex, okay. And I just use the A-tex because that's the vertex shader. And then when I pass it on to other shaders, I use, like the geometry shader, I would call it G. For the fragment shader, I'd call it F, just as a little thing. Okay, so A position, so actually what we want to do, now here's where we do the transform. So we're assuming a 10 by 10 grid, and we're going to just do a regular size. Okay, so we're going to do a constant size for now, and then we'll send it in and do it later. GL position, so we can actually do it right here, I believe. GL position equals A position So if you can think about this, what we're receiving is actually the quad. Okay, so it's 6 vertices, but we're really getting 6 vertices as pointed to by the indices. Okay, so A position, and then actually if we just send it through, we'll be able to see just the one quad right in the center. We're not going to transform anything. Okay, and then we want ATEX. That's gonna be an out. It's an outie. We're gonna go out FTEX. Okay, and that's a vector 2. So our FTEX, which is going out, is ATEX. So we're receiving it in, we're sending it out. Okay. And so next, because we are using the geometry shader, we kind of have to start over completely with this guy. Because look at it. Look at it. We have the random function in here, which we're not going to use. Not going to use random. We're not going to use time. Let's just pass out the vector 2, which is the A texture. So FTEX layout points in. And in fact, what we're getting in is 2 triangles. So hold on. Triangles? Is that what we do? I don't remember when it comes to this. Max vertices equals 128, that's fine, whatever. Out FTEX. So in order to do this, with the geometry shader, what you do is you emulate the vertex shader, and then you emit vertex. So basically, it's like you just get the data, and you can get rid of it or use it or amplify it or whatever. So what we have to do is get rid of all this stuff, basically. Point size is important, position is important, and the texture thing is important. I think we only want... Okay. I don't think I defined a size in the fragment shader. So let's see here. See? That's cool. GL point size. And let's just say 25 for starters. So then we receive it. GL point size equals. And then, wait a minute. Shoot, I forget how to do this. Do I have any other fragment shader from... Hold on, open file. Any other geometry shader stuff? Hold on. Type GS. Okay, probably this one or that one. Let's load them both and see what we got. All right, I forgot about this. Look at this. Points in, max vertices. What's the other one? Oh, see, this is better. This is better. Oh, triangles. Triangle strip. Oh, perfect. This is what I want. Hold up. This is what I want right here. So, geom, vector 2, geometry, okay, right here. So I was pretty close. See, I had triangles. Okay. I was just missing the, instead of triangles out, it's triangle strip. Max vertices equals 3. That's fine. Because we're not amplifying any geometry. Not yet. Okay, so where did I get that one from? This one? Okay, so out, texture coordinates. Right. So position goes out, texture coordinates go out. So let's just use all this. So in vs out, let's use this one. We don't need this other platformer one. So let's see if we can load prefabs. G open file prefabs vs. Okay, so here's the vertex shader. So this is for 3D stuff, but we just need this out vs out vector 2 text coord, and then see down there how it's okay. Hold on, let's copy this. So geometry shader. So this is going to replace this. So for our out variable, we use a structure basically, and the structure is called vs out, and then it contains the texture coordinates. What we can do is just call it ftex. That's fine. And then down here, vs out dot ftex equals atex. And then point size will go through, and position size. The reason I don't have to explicitly pass point size is because we're setting point size here in the vertex shader. So I don't actually have to worry about point size once I set it anywhere along the pipeline. So if I set it in the vertex shader, that's fine. If I set it in the geometry shader, it's fine there. But if I don't set it here, and let's say it's data, and then we're going to scale it or something, then we pass that through, then we would set it at a certain point. But as long as we set it at one point, we don't have to worry about it setting it later. I hope that makes sense, because now once I've set it here, like the texture coordinate, I'm passing through because we haven't used the texture coordinate yet. The position is also a default variable, so that gets passed along, kind of like the default variables are kind of like a river, and you can just throw stuff in there like the point size and the position. The texture coordinates are not, and so those are explicit variables that we're sending out. It's kind of like our custom variables. So there we go. So we have the position, we have the texture coming in. This is the out variable. It's in a structure, and then we are sending it out, and then these are built-in variables. And in fact, maybe I can even group those together like that. Okay, and then the geometry shader now. This is our out. So in the geometry shader, we need our in. And let's look at the geometry shader from here. See, this is the in. And this is where it gets a little bit weird, because we're switching from the in, which is called vs out, okay? And then this was ftex. GS in. Okay, I gotta go get some orange juice. I'll be right back. There we go. Okay, so the GSN is an array, and that array gives us access to all of the vertices in the triangle. It's per triangle. It's really weird to think about at this point. So we go VS out, and we get the texture here, and then out. But think about this. It's called VS out, but it's in. This is the in variable to the geometry shader, and this is a built-in array in the geometry shader. This GS in, or we're making it right there. Or wait, is this the built-in one? Sorry, this is the built-in one. Excuse me. Don't pay attention to what I say. Pay attention to what I do. So then the thing that we want to do, prefab here. So if we look at this one, the position is just passed through, so the built-in GL in goes through to position. So we actually need that, and then for n, let's see, do we have that? We have I. So this is the built-in geometry shader variable that receives the vertices as they come in. And if you use the length function, that gives you the number of vertices that you're receiving. So in this case, we just do 3, but I did, yeah. So let's go here and copy this. And we'll put it back here, because that's actually what we need. And I know there's a bunch of other calculations and stuff. We'll get to the calculations. So position ftex. So what you do is with each vertex, you prepare as if you're running the vertex shader. And then you call emit vertex, and then it's like, okay, the state of the GPU in this instance, send it through just as if the vertex shader was running. So that's what you're doing with the geometry shader. You're allowed to go in and create your own algorithm, and it contains the vertex shader, if you can imagine it like that. So you see in our vertex shader we have the texture going through, we have the position, and I already mentioned that the point size is already set. Now if we hadn't set the point size here, and we wanted to use the point size, we could set it here just as if this was the vertex shader. So like if our point size was variable based on I, we could just put it right in here. In fact, I think we even have access to the GL point size inside of this array, this GL in array. So if we wanted to access what each vertex is from the vertex shader, that's the whole point of the geometry shader, is we can access this array and then change it as we need. In this case though, we're going to array access, with the index of I. And then ftex is equal to gs in, and we're going to use I. Text coord. And then emit vertex. Now remember this, the size is already set. Of course, having said that, I probably have to go and set it. Okay, so this is just a pass-through geometry shader, which means that we're not really doing anything. So the position is equal to the position. We're not adding any extra geometry. So for each vertex that comes in, we're only emitting one vertex. So if we had another loop within a loop, or other algorithm or something, we could do that. We could add geometry right here. So there we go. I should probably explain less and make sure that this works first. So in our out, we have that. Oh yeah, and then we also have to call end primitive. Once we're done processing and creating vertices, or doing whatever algorithmic thing we're doing, we have to call end primitive. That ends the primitive. So that's the one thing that's different about the geometry shader, is that it actually is working with the whole triangle, the primitive. So if you're drawing triangles, so like when you're back in your function here, in the render function, this is not going to be points. This is going to be triangle. I think it's going to be triangles, triangle strip, something like that. We'll figure it out in a second, but yeah. And see, we're going to draw two triangles, but I think that's arrays. Draw elements instanced, which I don't think this is going to work. I think we're going to need to do a little bit more before we even get this going, but yeah. So we're still a ways off in that respect, getting it to work, but bear with me here. Okay, so end primitive. And I may have to actually eat and get my thoughts together. So I may be coming back to the stream. Okay, and then this is wrong too. So let's see if we can get that prefabs. Just to look, prefabs. That's a great one. Okay, so out. Yeah, okay, so in our shoot. Let's just, can I move this over? Okay, good. So now we have the fragment shader here and the fragment shader there. Let's move this over here. I like that. And I need that. Okay. So here is the prefab, and it does some stuff, but basically out frag color, in text chord, and then the sampler. Okay. Yeah, we'll need one of those. So let's copy that stuff. Okay. The fragment shader, in final color, out. Okay, so there's that. Okay, so and then we can just call this in ftext for text coordinate. Sampler, texture 1, let's just call it texture. Oh wait, yeah, texture 1. Okay. I don't know. Out frag color, so let's call it frag color. We are going to be sampling from the texture, so I think we use the texture command. And that's going to be it for the fragment shader, pretty sure. Let's double check this guy here. So frag color, texture, texture 1, and texture coordinates. Yeah, that's it. So then we don't need that anymore. And save that. Okay, this will not work though, because wait, what did I do for the position? Oh, this has to be, I think, yeah, this has to be a vector 4 going out, I believe. I forgot the position was a vector 4. Okay. Okay. So, you're telling me there's a chance. Okay, so out ftext, see, ftext equals GSN text chord out ftex. Okay, maybe we should hold on. Gtex, I forgot. Gtex equals atex. I think that'll make it a little bit more clear what's happening. And then in gtex, out ftex. I like that better. So ftex equals gs_in, and here gtex. So again, I just kind of wanted to show you GLin. That is the built-in default variable. And the GSin is the variable we defined and that we're passing through as a structure through from the vertex shader to the geometry shader. Okay. GS, GL, I know. Okay. So the ftex equals GS, which we defined and sent through from the vertex shader. GSin, gtex. Okay. So that is from the vertex shader. It's like our custom variable, and it's GL length. Okay, so I'm just going over this to make sure. Should probably just compile it and run it, but it's not going to work yet because we have the texture, but we don't have. What don't we have? Let's see. Save those for later. Okay, so those are all. I think we're pretty good as far as what we have with shaders. Whoops. Here. So, okay. Let me think about this. So the first thing we do is initialize the texture. Initialize VABEOs. I tell you. Okay, so VAO, VBO, EBO, VAO, VBO. Okay, vertices goes in there. Okay, indices goes into the element buffer. Okay, there's the position and the texture coordinates. Okay, unbind, but we don't really need to. Now we need to put in delete. Is this vertex buffer? I think that's that. We also need to delete element buffer. Is that a thing? Yeah. Okay, I don't think I've ever done that before. Because I don't think I... Well, I may have... I don't think I did proper cleanup, though. That's cool. Okay, it should compile, though, so let's run it and see if we even get anything. I don't think we will. We might even get errors. Okay, there is an error for building. Continue, run less successful, build now. Okay. Where's this? Oh, right. Assuming we don't do any drawing. Delete vertex buffer. Oh, there isn't such a thing. So, yeah, see, hold on. It's been a while. Let's... so where is the... Oh. Not that one. Which one did I get this from originally? It was class first, geometry random 2E. Okay. But like I said, I don't think my cleanup really does anything. Just deletes the vertex arrays. Okay. What am I looking for then? Delete buffers. Oh. Is that what it's called? Delete buffers? Okay. Okay. Okay, let's at least see if that compiles. It does. Doesn't draw anything. We do get errors in the geometry shader. Undefined variable I. Oh. Computer? Really? Undefined variable I. Wait, don't we... Do we just... Computer? Is that all we need? Hopefully. Yeah, that's better. Okay, so at least we don't have any errors compile-wise. Okay, now let's try to actually make this work. So for each one, again, to get this to work instanced, eventually we're going to need a grid size, we're going to need a grid scale, we're going to need a rotation. What are we sending through? What are we doing? Instance, let's just draw one instance, right? So, actually, hold on, let me look at this. This one. Computer, oh man, there's no... IntelliSense. Oh. Let's do it here. There we go. See, so we get mode. Let's go GL triangles. Size, count. Interesting. Count would be... Or wait. Is it... What do we do in the asteroids one? Hold on. Just copy it. That'd be better. 6. Oh, the type is unsigned int. And then 0 and 5,000. Oh. Oh. Well. Okay, in this case, GL triangle 6 unsigned int, 0 and not 5,000. We're just going to draw 1. But what was the 0? Let me go back and look at the main real quick. I want to... Type const void indices. Oh, that must be an offset into the indices. Okay, cool. And then instance count. So 0 is the offset to the indices. Instance count is 1, right? In this case, for the first one. Okay, so there we go. Ba-ba-bum bum bum bum. Ba-ba-bum ba-ba-bum ba-da-bum. Oh, whoa. Wait a minute. It worked. But wait. Oh, I sent in a point size. That has nothing to do with it. Right. Oh, okay, it worked. Cool. So we do need to sample into the thing. Okay, all right. We got a lot of stuff to do. Hold on. Okay, guys. I hate to cut this short right now, but we will be back. I'm gonna go eat, and then I will resume doing this. We'll do part 2 right after eating. Thanks for tuning in.